Thank you. Good morning, everybody. I will be very short here. I'm Lourdinha, and then this work is a part of MSc of Jessica that was not able to come, and then I have to quickly come. Well, water is essential for life. Everybody knows that. So, and not every place has enough water. Some place has a lot of deficiency, natural one, like a semi-arid climate in the world. But in Brazil, although we have 20% of sweet water in the world, we have also problem with water. Yeah, the water is not very well distributed there. And then we have an area that's about 1 million of square kilometer, like France and Spain together. That's 12% of all Brazilian area. That's really dry. It's a semi-arid region. The temperature there is average always above 25 degrees. The precipitation is below 400 millimeters, but only in 2 months. So then it's rain like today here, very quick, and then nothing later. And then, but in this area lives 28 million inhabitants, and then basically urban and rural area. The capitals of the states, here we have a very wet lands. Recife is here. Rainy 2,400 millimeters per year is very rainy, like, yeah, every day rain. But 50 kilometers from there, we have this huge area, very dry. But although that, many people live there, and especially in small communities. More than 50% is in community, about 5,000 inhabitants. So, these areas is one of most populated semi-arid region in the world, okay? Because many people, and then we have a hydric deficiency. So water scarcity is a reality, and in our lab, we have been working for a long time in this subject. So we work with, of course, in organic matter, industrial and domestic, nutrients removal, pathogen, that's very important, micropollutant, included glass, and resource recovery with several techniques, and water reuse, that's very important because of water scarcity. And then also we are, in the last 3 years, we are also working with wastewater basic epidemiology for SARS and also for bacteria resistant to antibiotic. Mario already started with presented something about last production in Brazil is very huge. It's a very big production in the world. And then, yeah, it is for cleaning and so on. And they have many problems, it's included in environmental problem, and then also the concentration is between 1 milligram per liter and 18 milligram per liter in the water, some water. We have several problems of scum in rivers, like in Sampaio, and then especially now that we approach the winter there, they always have a problem with this more low temperature. We have a more scum appear there, and it's a really problem. And so we have last that is already we know that's biodegradable by aerobic, but not completely biodegradable. We still have some part that's not biodegradable. Anaerobic also the same problem. They have a biodegradation, but not completely biodegradation. Yeah, and then obviously we need some additional step to remove it, and then chemical oxidation is one of them. For more detail about the thing, you can see papers that we produce in our lab. So, since it's not possible to remove the last completely biologically, we have to complementary treatment for achieve the standards for the water. So the objective of this work was to evaluate the removal of SLAS using chlorine as a post-treatment. Chlorine is very cheap product to use to disinfection in Brazil. We don't have any ozonation or UV for water treatment. Chlorination is very, very common. So we decided to study the degradation of LAS after anaerobic digestion. That I can here is a plant that is, we have a pilot plant there. And then after the USB reactor and before the post-treatment. And then the characterization of the general characterization of the wastewater is common. Wastewater after anaerobic treatment, some pH, temperature is very high, always above 25 degrees, and then solid, and they still have some COD, is some ammonia nitrogen, okay? So this is of concern about when you use chlorination, but it's not present here in this part. So we collect the sample, then we have to make a filtration because not possible to chlorinate with big particles. We have to remove in order to be more efficient for chlorination. And then we tested 3 ways of chlorination. Because most of communities is very small, it's very difficult to bring them the liquid chlor because it's very expensive and then more difficult to have more skill to spread in the area that people are more, they have lack of specialized people. So we have to use a more simple way of chlorination like sodium hypochlorite, calcium hypochlorite, and also generate chlor in loc by electroactivated water. When you do that, we also generate another compound like oxygen peroxide and ozone. And then we said, oh, maybe it would be nice to test it. And then we did, all test was made by jar test. We now is put for continuous not in jar test, now we have, okay. And then test several doses of chlor, 5, 10, and 15, that's, and then the contact time, that's very important when you do chlorination because we were also looking for other things like disinfection. And then the results. The last was made by gas chromatography, HPLC, and then the initial concentration of the last was on average that was is found easily in all anaerobic reactor, 1.6 to 2 more or less. So then we start. Here comes out the result for rotation time of 10, but surprisingly for 20 or 30, no difference in the result. Means that maybe 10 is even too much time for this reaction. Probably it's immediate reaction. So they are already investigating a little bit more deep above this value, the difference between them. When we see the all data together, because it was hundreds of experiments, and then we see that in fact calcium hydroxide is much more consistent in the result. Although the sodium hypochlorite is also good, above 75%. However, they are not really, it's very spread, Then also the electroactivated water is the second best. When we compare the national Brazilian legislation, we see that for fresh water, calcium hypochlorite attend not only fresh water but also brackish water and saline water that is a bit lower, and then but they attend all. Sodium hypochlorite is not so good, is a little bit bad in comparison to the legislation, and for the electroactivated water, yeah, some can be improved. So we can conclude that it's possible to remove loss by chlorination. This residual loss is best up to now. Is best to use calcium hypochlorite followed by electroactivated water, and then intermediate compounds by chlorination is under evaluation, like type of compound, methylamine. Or other compound, and then also their toxicity. That was we are Messi for everyone, and then this is all the group that we are a very big group, and then we have many found of our lab. Then here is for all, so not forget anyone. And then we also welcome you in Recife, it's a beauty city. Yeah, sorry. I stop. Look. Back to the beginning. It's a secret.